The formation of Earth, along with the rest of the solar system, is believed to have occurred about 4.6 billion years ago. This process is known as the solar nebula theory and involves the following stages. Nebula formation. The solar system's formation began with a massive cloud of gas and dust called a solar nebula. This nebula was primarily composed of hydrogen, helium, and small traces of other elements. Collapse of the nebula. Some event, such as a nearby supernova explosion or shock wave from a passing star, caused the solar nebula to start collapsing under its gravity. As it collapsed, the nebula started to spin faster, forming a rotating disk shape due to conservation of angular momentum. Protoplanetary disk formation. As the solar nebula continued to contract and flatten into a spinning disk, the central region became denser and hotter, eventually leading to the formation of the Sun at the center. Surrounding the Sun was a protoplanetary disk, which contained gas, dust, and solid particles. Accretion of planetesimals. Within the protoplanetary disk, dust particles began to clump together through various processes, such as electrostatic forces and collisions. These clumps grew larger and larger, eventually becoming planetesimals, small, primitive celestial bodies. Planet formation. Over time, planetesimals continued to collide and accumulate more matter, becoming protoplanets. These protoplanets, still embedded in the protoplanetary disk, cleared their orbits of debris through gravitational interactions and became the building blocks of the planets we know today. Differentiation. As the protoplanets grew larger, they heated up due to the energy generated by the decay of radioactive isotopes and the energy of collisions. This heat caused them to melt and undergo differentiation, with heavier materials sinking to the core, forming a layered structure. Formation of Earth. The planetesimals that eventually formed Earth continued to collide and accrete, eventually creating a planet with sufficient mass to develop a strong gravitational pull. Earth's core consists mainly of iron and nickel, surrounded by a mantle of silicate rocks and a thin crust at the surface. Late heavy bombardment. After Earth's formation, there was a period of intense bombardment by asteroids and comets known as the Late Heavy Bombardment. This event, occurring around 4.1 to 3.8 billion years ago, played a significant role in shaping Earth's surface and may have influenced the development of life. The process of Earth's formation was a dynamic and complex interplay of gravitational forces, heat, and matter, eventually giving rise to the planet we call home.